class, let's go ahead and knock this out. Exercise 8.7, it says 1 and 2, find f plus g to x, times x, and f minus g times x, and state the domain of each. Then evaluate f and g, or f plus g, and f minus g for the given value of x. Oh boy. All right, well, let's go ahead and give this a shot. First of all, says find f plus g times x and f minus g plus x. I have number 1, so I'll work that one out. So if I'm doing f plus g, this is going to be x squared plus 3, x minus 18. Remember, we're adding this, which means I'm going to add it to negative 2x minus, or plus 6, excuse me. When I put these together, I'm going to get negative 18 plus 6, that's negative 12. 3 minus 2, that's going to be x, positive x, and then x squared. All right, so that's going to be my answer for the first part. I'll just put it over here, x squared. I'll leave the work there. Let's go to the next one. Now it says, let's see, now we're going to do f minus g. So on the f minus g, this is going to be, let's see, I would say x squared plus 3x minus 18. This time we're going to subtract this, and that's going to turn all of these signs the opposite. So this will be now a positive 2x and a negative 6. I don't know if everyone remembers that. And you have a negative in front. So this is negative 2x plus 6. That means all the signs will become the opposite. They're actually adding. Negative times a negative is a positive. Negative times a positive is a negative, right? That's where we got this right here. So now we got negative 18 plus 6 is 24. And this would be 5x, positive 5x. This is still x squared. Now, let's see, I'm going to take this and erase it over here so I can get to the next part. Now it says x is going to be 3. So if x is 3, I would say this is going to be x squared. Right, this is, I'm sorry, I'm going to change this out. See, instead of x squared, it's 3 squared plus 3 minus 12. Well, 3 squared is going to be 9. 9 plus 3 minus 12. And 9 plus 3 is 12. And 12 minus 12, that's 0. Now let's work this next one over here. If x is 3, then this would be 3 squared plus 5 times 3 minus 24. Oh no, 3 squared is 9. 9 plus 15. 3 times 5 is 15. Minus 24. Well, 9 plus 5 is 24. I have 24 minus 24, and that equals 0. So when I evaluate each of these, I'm going to get a 0 answer for each of them. I did forget one little thing. It said state the domain and the range. And since we're talking quadratic equation, that means it's going to go on, let's see, it's positive, so we know it's going to have on the graph, it's wherever it is, it's going to, well, it's crossing through negative 12. I'm not quite sure, but I do know that it's going to be a parabola. That means it's going to be all real numbers. This one also is a positive parabola, all real numbers. So so both of these will be all real numbers. right, let's see how we did. All right, so for the first part, x squared plus x minus 12, that was correct. All real numbers, that's correct. And looks like 0 was the answer. Yep, 0 was the answer over here. And for the second one, x squared plus 5x minus 24, that's what I have here. Again, all real numbers. And again, the answer was 0. So that's how you work number 1. You got number 2. Let's move on. Number 3 says this time we got f times g to x and f divided by g to x. Okay, well, I've got number 3. So let's put it to work. So in this one, we've got x squared plus x plus 9. And we're multiplying it to negative 4x minus 3. I showed you guys how to multiply this in class. You guys can do it the FOIL way if you want. I kind of prefer it this way. So 9 times a negative 3 will give you a negative 27. X times negative 3 will give you a negative 3x. And x squared times negative 3 is a negative 3x squared. Then we got negative 4x times 9. Remember, this is a 0 over here. We're going to have to put 9, that would be 36. So this would be a negative 36x. And then a negative 4x times x would give us a negative 4x squared. And then negative 4x times x squared, that's going to give us a negative 4x to the third power. Then we have to add all these up. We got a negative 27. We have a negative 39x. We have a negative 7x squared. And we have a negative 4x cubed. All right, next we got to find the domain. This is negative, but let's please remember. Let's see, we got 4 here. This is still going to give us a parabola that even if it goes upside down, it's going to be all real numbers. So we put all real numbers there. And then let's see. Now we got to replace x with, it looks like they want us to use, let's see, multiply this to this, and then they want us to use negative 1. Okay, so that means we'd have negative 4 times negative 1 to the third power minus 7 times negative 1 to the second power minus 39 times negative 1 minus 27. When I do this, it's going to be negative 4 being multiplied to negative 1. Because 1 times itself 3 times is still 1, but negative times a negative times a negative will give us a negative answer. This is going to be negative 7 times 1, because negative 1 times negative 1 is 1. And this is going to be, well, negative times a negative, that's positive 39, and negative 27. Now I got a negative times a negative, that gives me a 4. Negative times a positive, that gives me a negative. And we have plus 39 minus 27. Well, let's see. I can say that 4 plus 39 will give me 43. And then negative 7 and negative 27 will give me negative 34. And now I have 34 or I can just put it this way, negative 34. And that's going to give me, well, it's like 9. All right, so the answer to the first one, which we're multiplying, right, is going to be 9. And we do f times g times x. All right, next we got to divide it. So let's go ahead and we'll take a negative 2. I'm sorry, I was looking at the wrong one. That's number 4 for you to do. Let's see, this would be 8. Oh, I just keep writing the wrong thing. Sorry. Try this one more time. X squared plus x plus 9. And we're going to be dividing that by negative 4x minus 3. Now remember, this bottom one is the one that matters here. We're going to have to go ahead and work that one out. So in doing so, let's see. That means we're going to be taking this negative 4x minus 3, putting it to 0. To solve this, we'll have to add 3 to both sides. That's going to give me a negative 4x equals 3. And we got to divide by negative 4. We get x by itself, and that means x will be equal to negative 3 over 4. All right? And now it's saying they want us to go ahead and work this out again with negative 1. So let's see here. That was, oh, I'm sorry. We were still working on the domain, weren't we? So the domain cannot be, all real numbers except the domain cannot be negative 3/4. Okay, so I guess to say x cannot equal negative 3/4. Okay, now let's work this one out using negative 1. If I did, that's going to be negative 1 squared plus negative 1 plus 9. It's going to be over negative 4 times negative 1 minus 3. Okay, so negative 1 squared is just 1, because a negative times a negative is a positive. Positive times a negative, that's 1 minus 1, and then plus 9. Then we have negative 4 times negative 1, that's 4, then minus 3. Well, negative 1 minus 1 is 1, so that's going to equal 9 on top. And 4 minus 3, well, that's 1. And 9 over 1 equals 9. So that's also 9. So now we have, that is going to be when we make x to negative 1. Let's see how we did. And there we go. The first one, we add them. We get negative 4x cubed minus 7x squared minus 39x minus 27, just like we have here. we said that it would be all real numbers. The domain is all real numbers. And we said when we worked it out with x equal -1, we would get 9 for an answer, and we did. The next one, we divided it, right? That's exactly what we got here, x squared plus x plus 9 over -4x minus 3. It would be all real numbers except that it cannot equal -3 over 4. And when we worked out, we would still get 9. All right, let's move on to number 5. The dimensions in inches of a rectangular tile can be modeled by ax equals x squared plus 5 and bx equals 2x minus 1. Find a plus b times x and a plus b times x. Evaluate, a plus b times x and a times b times x. Evaluate and interpret each expression when x is 4. Then explain what the expression ab times x represents. So let's work this first of all. Part A, we're doing a plus b times x. This is really taking, we're going to get this number, remember we're adding it, right? So I'll just kind of work it out really quick here. We're adding it, we're going to be taking the -1 and putting it under here. There is no x to the first power. So we can just go ahead and put it over here, plus 2x if you want to. And then when we bring this down, it's going to give us x squared plus 4 plus 2x. And of course, we're going to put these in order. So we'd have x squared first, and then plus 2x, and then plus 4. Now you can see where we got this one here. Now we're talking multiplication. Again, we're going to multiply these two together. So we'll work that over here. If I have x squared plus 5, and multiply it to 2x minus 1. Well, we know x, or 5 times -1 is going to give us a -5. Then we got -1 times x squared. Well, that's just going to be a -x squared. We really need to put this over here because we don't need anything in the singular x part. Over here, 2x, we're going to have an O here, and then we have 2x times 5 will be 10x. So this would be 10x right here, where x is going. Then we got 2x times x squared. That's going to give us 2x cubed. It would not go in the same category column as the one here. So this would be plus 0 here as well. Now when we add it all, we get -5. We get our, this was positive 10. So this is positive 10x. And then this -x squared. And this 2x cubed. And that's what we get, 2x cubed minus x squared plus 10x minus 5. All right, next it says, that was evaluating, or find, now evaluate and interpret each expression when x equals 4. Okay, so now we've got to take 4 and put it in over here. So if I do that, I'm going to have 4 squared plus 2 times 4 plus 4. Well, 4 squared, that's 16, plus 8, plus 4. Well, this is 16 plus 12, and 16 plus 12 is equal to 28. And that's where they got 28 right over here. Next one, we're going to be replacing that with 4, and so that's going to be 2 times 4 times 4 to the third power, excuse me. Then minus 4 to the second power, plus 10 times 4, minus 5. Well, 4 to the third power, that's 64. So we got 2 times 64. And then we got minus 4 to the second power, that's 16. And then plus, well, 10 times 4, that's 40. Then minus 5. 2 times 64 is 128. Now minusing 16 plus 40 minus 5. We're going to add all the positive numbers together. 128 plus 40 is going to give me 168. Negative 16 minus 5 will give me negative 21. So now we're just going to minus 21 from here. And this should give me a 7. This should give me a 4. And this should give me a 1. And that's where we got the 147. All right, so when x is 4, the area of the tiles is 147 square inch. Okay. And let's see, the sum of the dimensions is 28. Now it says, explain what the expression AB times X represents. Well, that represents the area of the tile in square inches. All right, time to move on. Number 6 is yours to do. Good luck on that one. Number 7, analyze the relationship. The population of the town in 1980 was 3,000. Population of the town A increased by 20% every decade. Let X represent the number of decades. Since 1980, the graph shows the population of town B. Compare the population of the town by calculating and interpreting the average rate of change from 2000 to 2020. Well, from 2000 to 2020, the population of the town A increased at an average rate of about 950. Okay? So let's hear it. From 2000 to 2020, the population of town A, remember this is town A, right? It was, we're asking from 2000, well, this was 1980. So we're looking at 2000. Let's see. The population of the town A increased by 20% every decade, and a decade is 10 years, right? So every time 10 years went by, it increased by 20%. Okay, so how do you find that? Well, let's go over here. Remember, it was 3,000. And we'd have to take 3,000 and multiply it to 1 plus 20%, which would be 0.2, right? And then for every year, well, how many decades went by before it was 2,000? 2 decades, so that would be 2. So that gives me 3,000 times 1.2 times 2. I'm going to have to work this 1.2 times 2 here. 1.2 times 1.2. That's going to give me 4, 2. And we're moving these over twice. And then this is going to be 12. That together would be 144. And we have to move 2 decimals over, so that's going to be 3,000 times 1.44. So let's work that now. Wow, 3,000 times 1.44. Well, to make this a lot easier, I'm going to take 1.44. I'm going to multiply it to 3,000. And that's because all those zeros will mean nothing in multiplication. I'll just be adding zeros, right? And then I can start right here. 3 times 4 will give me 12. Carry the 1. 12, and that would be 13. Carry the 1. And then I've got 3 plus 1 is 4. and we move that decimal over twice. So the new population is going to be 4,320. All right, so it says, let's see, it increased by 950. So let's see how they got 950 from 2000 to 2000. Oh, I'm sorry, to 2000 to 2020. That was actually 4 years. Wow, I'm going to have to stop this for a second. Sorry, there's no way I could let this video be that long. So I decided to go ahead and let the answer be written out, and that way I could explain it a lot quicker and you wouldn't wait for me to write. This is where I was at when I found it at 2020 or year 2000, year 2000. And to get to year 2020, that would be 4 decades. So over here, they put a 4 in place of that 2. And then they came up to 6,220.8. Now, to find the average rate of change, you had to take 6,000, the big number, right? Well, this is counting like the Y. This would be counting as the X. So we're going to be taking 6,220.8 and minusing the 4,320 and putting that over 4 minus 2. That's going to give us 1,908 divided by 2, which is 950.4. All right, so let's see. That was the first town. Now we got town B. We're going to use the graph to estimate that when X is 2, that Y is going to be, well, it looks like about, let's see, if this is 4,000, it should be 4,500. So it'd be really close, probably 4,900, which they have right here. And that would mean when X is 4, this is going to be right here, right? That's going to be 6,250. All right. And now we take 6,250, we minus 4,900 from it. We take the 4th year, right? And then we minus the 2nd year. Still, we're going up by 2 decades and then 4 decades. And that's going to give us 1,350 divided by 2, which is 675. So from 2000 to 2020, the population of town A increased at an average rate of 950 people per decade. The population of town B increased by an average rate of about 675 per decade. So the population of town A is growing faster. All right, let's go on to number 8. I believe that was yours to do. So I'm going to go on to number 9. Good luck at number 8. So number 9 says let X represent the number of years since 1970 to the function h of x equals 10x squared plus 10x plus 500 represents the population of Oak Hill. In 1970, Poplar Grove had a population of 200 people. Poplar Grove's population increased by 8% each year. So from 1970 to 2020, which town's population had an average rate, a greater average rate of change? And so let's do that one first. I'm just going to have to move this out of the way. I'm sorry, the writing is going to be kind of small today. So write the expression to model the population of Poplar Grove. Okay, Poplar Grove, remember, had a population of 200 people and increased by 8%. So we're going to take that 200, multiply it to 1 plus 0.08. That's 8%. And then x is going to equal the number of years. So our function would be 200 times 1.08. Now remember, we're talking 1970 here, and we went from 1970 to 1920, excuse me, to 2020. That looks like a total of 5 years. So let's see. Yeah, from there to there would be 5 years. So over here it says find the population of Oak Hill and Poplar Grove in 2020. So it says Oak Hill, they're solving Oak Hill first. And they said they got that formula, and you're replacing it with let's see, represent the population. Okay, so they came up with 50. So they're saying find the population of Oak Hill and Poplar Grove in 2020, find 50, because that's 50 years that went by. So when you put 50 here in place of X, you're going to end up solving this to be 26,000. Now, Poplar Grove, remember, was 200 times 1.08, and now we're going to put that to the 50th power. When we solve that, that'll be 9,380. So now, once again, we're going to take the 26,000, right? And we're going to be minusing the 500. And then we're going to take, this is Oak Hill's average now, right? Because we started with 500. That was the starting point. And let's see. Then we're going to take 50, because that's 50 years minus 0 years. So now we've got 25,500 divided by 50, which is 510. Poplar Grove, on the other hand, we have that 9,380. We're going to be subtracting the 200 that we started with. And then we're putting that to 50 over 0, because that's 50 years minus, at the beginning, 0 years that went by. That's going to give us 9,180 divided by 50. That gives us 183.6. So as you can see, the population of Oak Hill grew greater, right? From 2020, the population of Oak Hill increased at an average rate of 510 people per decade, and the population of Poplar Grove increased by an average rate of 183.6. So Oak Hill had a greater average rate of change. All right, so B says, which town will eventually have a greater population? Well, Poplar Grove will, right? It can be modeled by an increasing exponential function. And Oak Hill's population can be modeled by a quadratic function. So Poplar Grove will eventually have a greater population, okay? Even though Oak Hill started with more, Poplar Grove will grow quicker. All right, let's go ahead and move on. You have number 10. I got number 11. It says, explain why the average rate of change in a linear function is constant. The constant rate of change in a quadratic or exponential function is not constant. Well, that's pretty easy. The average rate of change of a linear function is constant because the dependent variable of the linear function increases by the same amount for each constant change in the in the independent variable. Now, the average rate of change in the quadratic or exponential function is not constant because the dependent variable of the quadratic or exponential function changes by a different amount for each constant change in the independent variable. And that's about all I can say about that. You have number 12. I'm going to go on to number 13. I think that's my last one. You sell baked goods at a community event. Your revenue can be modeled by R of x equals 7x squared minus 6x plus 2. And your profit can be modeled by P of x equals 7x squared minus 11x plus 10, where x is the number of goods sold. Find a function that can be used to model your costs, justify your answer. So the profit is the revenue minus the cost, right? So the cost is found by subtracting the profit from the revenue. It says here that the revenue is this function and the profit is this function. We're going to be taking the profit, right? Actually, the revenue, right? And we're going to be, found by subtracting the profit from the revenue. So we're taking the profit and subtracting it from the revenue. So that means we started with 7x squared minus 6x plus 2. We're subtracting 7x squared minus 11x plus 10. That means all these signs will become the opposite. It'll now be negative 7x squared, a positive 11x, and a negative 10. When we combine these, 7x minus 7x is 0. Negative 6x plus 11x is 5x. And negative 10 plus 2 is negative 8. And that's why they got 5x minus 8. All right. Number 14 is yours to do. I believe that was all of them. And I'm cutting this video short. It was already too long. Have a great night, and I'll see you in class.